Hi friends, welcome to Limitless Learning Platform. I hope you are fine. Today we have discussed about chemical kinetics. Basically this chapter deals with the rate of chemical process under some given conditions like temperature, pressure, concentration, etc. In brief comparison or correlation with classical thermodynamics can predict visibility and direction of a process, but it fails to predict the mechanism of the process. On the other hand, chemical kinetics can predict the mechanism of a process and also give idea about the time dependence of the process. So we say that both the chapters are complementary with each other to know in details about a chemical process. In this video, we have covered the following topics, where first we will learn how to write rate of a chemical reaction. Then we describe one by one about rate law, order of a reaction, molecularity of a reaction, and finally we will find the difference between order and molecularity of a reaction. Now moving on, first topic, that is rate of a chemical reaction. Rate of a reaction is defined as the rate of the change of the concentration of the reactant and product at any instant of time. Considering hypothetical reaction A to B and assuming at time t concentration of A is Ca. So, according to definition, rate of a reaction in terms of reactant is minus dCA by dt. Here, the negative sign indicates decrease in concentration of reactant with time. Always remember, when we will write rate of a reaction in terms of reactant, we will always give negative sign. Students sometimes forget to give negative sign for defining rate of a reaction in terms of reactant. That gives wrong meaning. Now we assume that at time t the concentration of V is Cv. So rate of a reaction in terms of product will be dCv by dt. Here positive sign indicates increase in concentration of product with time. So for A to B reaction, rate of the reaction R is equal to minus dCA by dt equal to dCv by dt. I hope you have understood how to write rate of a reaction. Now moving more complex scenario to express rate of the reaction. Considering the example 1 mole nitrogen and 1 mole oxygen reacts to form 2 mole nitrogen monoxide. In that case, rate of reaction is expressed in terms of change of concentration of each reactant or product per mole. Once again repeat the line, listen carefully. Rate of reaction is expressed in terms of change of concentration of each reactant or product per mole. Here the key terms to give emphasis are each reactant, each product and per mole. So in this example, rate of the reaction R is equal to minus dCN2 by dt for nitrogen molecule is equal to dCO2 by dt for oxygen molecule is equal to half of dCNO by dt for nitrogen monoxide. Here, in this reaction, 2 moles of nitrogen monoxide is formed. So, here 1 by 2 term is multiplied with dCN by dt. I hope up to this you have understood well. Now, moving final example, A moles A and B moles B reacts to form M moles M and N moles N. Now pause the video and write down the rate of the reaction. I hope you have written the rate of the reaction. The answer is R is equal to minus 1 by A into dCA by dt is equal to minus 1 by V into dCV by dt is equal to 1 by M into dCm by dt is equal to 1 by N into dCn by dt. I hope you have learned to write rate of a reaction. If you are facing difficulties to understand, please repeat this topic before moving further, and also never forget to write difficulties in the comment box. That help to improve myself also. Now moving next topic, that is rate law. A rate law demonstrates how the rate of a chemical reaction depends on the concentration of reacting components. Let's elaborate in detail by example, considering previous example as A to B reaction and assume rate of the reaction depends on the concentration of the reactant. Then rate law is minus dCA by dt is equal to dCV by dt is equal to K into Ca, where K is proportional constant called rate constant. So rate constant can be defined as the rate of a reaction where the concentration of each reacting component is unity. Always remember that rate law can only be expressed on the basis of experimental data and it has no relation with stoichiometric equation of a reaction. Once again repeat, listen carefully. Rate law is only expressed on the basis of experimental data and it has no relation with stoichiometric equation of a reaction. The given example will clear the concept. In decomposition of hydrogen peroxide, 2 mole of hydrogen peroxide decomposes to form 2 mole water and 1 mole oxygen. But experimentally it was found that the rate of decomposition of hydrogen peroxide depends on single power of hydrogen peroxide concentration and this is a first order reaction. I will discuss later about the order of a reaction. So, rate law is that rate of the decomposition of hydrogen peroxide is equal to rate constant into concentration of hydrogen peroxide. I hope you have understood about the rate law. Now moving next topic, that is order of a reaction. The order of a reaction is the power to which the concentration of a component is raised in the rate law equation, and the overall order is the sum of the powers of the concentration terms. Considering general example, A moles A reacts with B moles B to form M moles M and N moles N. Now, assuming rate law of the reaction, rate is equal to rate constant K into concentration of A to the power X into concentration of B to the power Y. So, according to the definition of order, the reaction is xth order with respect to A, the reaction is yth order with respect to B, and the overall order of the reaction is x plus y. Now I can believe you have understood what is order of the reaction. Some key points you should remember. Order of a reaction can only be determined experimentally and it cannot be predicted with stoichiometric balanced equation of a reaction. Order can be fraction, 0 or even negative value. As example, the decomposition of acetaldehyde is 1.5. The question may arise in your mind, how is it possible in reality? Actually, reaction has been occurred in multi-steps and order has been determined for overall reaction. Here I answer in briefly in one sentence. We will discuss later when we will go more in depth in this area. Now moving next topic, that is molecularity of a reaction. The molecularity of a reaction is defined as the number of reacting molecules simultaneously involved in a chemical reaction. Always remember that the reacting molecules must involve simultaneously in a reaction. For example, A to P reaction, number of reacting molecules simultaneously involved is 1. So molecularity of the reaction is 1. The reaction is called unimolecular reaction. Next example, 2A to Q reaction. Here number of reacting molecules simultaneously involved is 2. So molecularity of the reaction is 2. The reaction is called bimolecular reaction. Now write down the answer within 5 seconds. What will be the molecularity if A reacts with 2B to form R and S? I guess everyone write the correct answer. Here, The number of reacting molecules simultaneously involved is 3. So, molecularity of the reaction is 3. The reaction is called trimolecular reaction. Some key points you should remember. Molecularity must be integral value. It cannot be negative, zero or fraction value. For elementary reaction, that is single step reaction, order and molecularity found to be same. For complex reaction, that is multi-step reaction, overall molecularity is insignificant, but each step has specific molecularity. It may be difficult to understand the last point. Don't worry. Let's consider an overall reaction. 2A reacts with 3B to form M and N, and assuming reaction has occurred in 4 steps. In first step, A reacts B to form C and D. So, the number of reacting molecules simultaneously involved is 2. So, molecularity of the reaction is 2. In next step, B reacts with intermediate products C to form E. So, in this step, molecularity of the reaction is 2. In third step, B reacts with D to form F. So, in this step, molecularity of the reaction is also 2. In final step, A, E and F simultaneously react to form M and N. Here the number of reacting molecules simultaneously involved is 3. So molecularity of the reaction is 3. So here we can easily say the molecularity of the reaction in each step. But in the overall reaction, we never say overall molecularity. So here the term overall molecularity is completely meaningless. I hope everyone understood. Now, the common question most frequently asked in examination or in interview, that is, what is the difference between molecularity and order of a reaction? Molecularity must be integral value, but order can be even negative, zero or fraction value. Order of a reaction can only be determined from experimental results, whereas molecularity is given on the basis of some proposed mechanism of the reaction to satisfy the experimental findings. Thus, molecularity is theoretical concept. As order of a reaction is determined from experimental results, we can determine the overall order of a multi-step reaction. But overall molecularity is meaningless for a multi-step reaction. As molecularity is theoretical concept, it does not depend experimental conditions, but order is dependent on experimental conditions like temperature, pressure, etc. Now it's time to give home tasks. Write what is the difference between molecularity and order. Try to write down answer within 2 minutes. Before ending the video, a quick look what we have learned. First, we have seen classical thermodynamics and chemical kinetics are complementary with each other to know in details about a chemical process. Then we have learned rate of a reaction, rate law, order of a reaction. Finally, we have learned molecularity of a reaction and find out the difference between order and molecularity. Thank you for paying attention. If you like the video, don't forget to click the like button. Have a nice day.